This is part 2 for the Chapter 3 Summative Assessment Review, problems 5 through 9. For problem 5a, for the graph you need to write the equation of the line in slope-intercept form, y equals mx plus b. So in order to write it in slope-intercept form, y equals mx plus b, the m represents the rate of change or the slope of the line. So I can take any of the points, the lattice points, that's where these two lines intersect on the graph, and they intersect here, and I can take any 2 points and do the rise over run. This rises 2 and runs -1. Well, that's 2 over -1. 2 over -1 simplifies to -2. I also could do -2 and +1. -2 divided by +1 is still -2. I could also do, and again, any 2 lattice points, rise 4, run -2. Well, 4 divided by -2 is still -2. So it's any 2 lattice points. To get the b, or the y-intercept is where your line intersects with the y-axis. So I always highlight the y-axis. You can easily see where these two intersect, and it intersects at -1, -2, -3, -4, at -5. So we have the y-intercept is -5, so the equation for this line is y equals -2x minus 5. For b, using the given table, write the slope, y-intercept, and the equation. In order to find the slope, or rate of change, you look at the difference between the y's over the x's. So, difference of the y's, you can see that from 8 minus 2 is 6. 2 minus 0 is 2. Or you can say 0 plus 2 is 2, 2 plus 2 is 4, 2 plus 6 is 8, 8 plus 6 is 14. So the difference between the y's over the x's is 6 over 2. 6 divided by 2 simplifies to 3. So the slope of this of this table equals 3. Now for the y-intercept is when x equals 1. If you think of a graph, the line is going through the y-intercept when x is 0. So you just look for where x equals 0. When x is 0, y is 2, so the y-intercept for this table is 2. Now we have everything to write this equation in slope-intercept form, y equals mx plus b. The m equals 3, or the slope, rate of change. The b, the y-intercept, is 2. So y equals 3x plus 2. Problem 5c, write the equation of the line in slope-intercept form, y equals mx plus b, when the slope equals 3 and passes through the point 2, -5. So we want to put it in slope-intercept form, y equals mx plus b. What was given to us is the slope, 3. Now we need to find out, well, what is the b equal? What is the y-intercept? In order to do that, we can take the given points, the x and y, and plug it into this equation. If we know x is 2, we can plug it in, x is 2. And we know y is -5, we substitute y with -5. Now we can solve for b. That's the only variable or unknown we have. So now we simplified this equation and solve for b. 3 times 2 is 6. Still don't have b by itself. Inverse property of addition is subtraction, so we're going to subtract 6 from both sides, created a 0 pair. -5 and -6 equals -11. So we have b equals -11. So now we have everything to write this in slope-intercept form. The slope was given to us, the m, and the b The y-intercept we just solved, which equals negative 11. Problem 5D, write the equation of the line in slope-intercept form, y equals mx plus b, that passes through the points 10, 6 and 8, 2. So we need to be able to find the slope and the b, the y-intercept. So in order to do that, if you have two given points, to find the slope, you use the slope formula, difference of the y's over difference of the x's. So I'm going to subtract y2 minus y1. So I'm going to identify this as y2, this y1. I could do this y2 and this y1, but I'm going to put this as y2. So I have 2 minus 6, y2 minus y1, divided by x2 minus x1. So x2, 8. Here's 8 minus 10. 2 minus 6 is negative 4. I have more negatives than positives, so I know it's a min negative. And 8 minus 10, more negatives than positives. Signs are opposite. You subtract. 10 minus 8 is 2, so it's negative 2. A negative divided by a negative is going to be a positive. So negative 4 divided by negative 2 is positive 2. So now we have the slope, m equals 2, or the slope equals 2. So we have this. Now we need to go ahead and find the b, or the y-intercept. Well, we did that in the previous problem when we were given the slope. So we were given the slope. We found that, which is 2. Now we need to find the b value. And in order to do that, I need to know the values for y and x. Well, I have 2 points that have the x and y values, so I can choose either of these 2 points to substitute into this equation. And I'm going to go ahead and choose 8 and 2. I could have chosen 10 and 6, but I chose this, this coordinate. So 8 and 2. So x equals 8 and y equals 2. So now I'm going to go ahead and solve for the b, the y-intercept. 2 multiplied by 8 is 16. Inverse property of addition is subtraction, so I'm going to subtract 16 from both sides. That creates a 0 pair. 2 minus 16, I have more negatives than positives, so I know it's going to be a negative. And when the signs are opposite, you subtract, so 16 minus 2 is 14, so it's going to be negative 14. And I get b equals negative 14. So now I have the slope, and I have the y-intercept, and I can go ahead and put that in slope-intercept form. Y equals mx plus b. The m is 2. The b, the y-intercept, is negative 14, so y equals 2x minus 14. For problem 6a, I need to identify the transformation that would carry the pre-image to the image as a translation, reflection, or rotation. Then specify the rule for each transformation. So to identify the transformation, I need to determine, well, which one's the pre-image and which one's the image. For problem 6b, I need to determine which one is the image and which one's the pre-image. Well, I can tell that this is the image because the vertices have the prime marks. P, Q, R, S prime. So this is the pre-image, so we're going from here to here. And I can tell that the orientation has not changed. It hasn't rotated or flipped or reflected over a line of reflection. So it has the same orientation, so that's telling me that it's being translated. It's being slid from here to here. And I can see that Q to Q prime is 1 unit up and 1, 2, 3, 4 units to the right. So the rule is we're translating PQRS 1 unit up and 4 units to the right. And I can tell by the prime marks here, this is E, F, G, H prime, that this is going to be the image. The pre-image, or the image I start with, is E, F, G, H. So I'm going from here to here. And how am I doing that? Well, it looks like if I rotate this, I would get this image here. And I'm going to go ahead and turn my paper. If I rotate my paper, here's E prime. E prime is at -4, -2. If I rotate this, you can see that here, this is where E prime was at -4, -2. So the type of transformation is a rotation about the origin. It's a rotation. And what is the rule? Well, I'm rotating this clockwise, the way a clock moves, and it's 1/4 turn, so that's 90 degrees clockwise rotation about the origin. Or I could do 270 degrees counterclockwise to the left. There's 90 degrees, 180 degrees, one more turn, 270 degrees, and there I would get my image. So either 90 degrees clockwise or 270 degrees counterclockwise would be the rule. For problem 6C, I need to determine the type of transformation. And if I look at this, I can see that it's giving me that butterfly effect, or a copy of a picture from one side of a page of a book to the other. If I fold this over, it would match up with the other side. So the type of this transformation would be a reflection. And it's reflecting on this line of reflection of x equals -3. So the rule for this would be to reflect triangle JKL over the line x equals -3. And this line here represents x equals -3 on the x-axis, -1, -2, -3. So this whole line represents x equals -3. So we're again reflecting triangle JKL over x equals 3. You can see k is 1 unit to the left, k prime is 1 unit to the right. J and J prime share that it's on the line of reflection. L is 1 unit to the left, L prime is 1 unit to the right. Problem 7, give the function f of x equals 8 minus 3x. What is the input if f of x equals 12? Well, remember, input's the x value, output's the y value. So we're trying to find the x value. We know what f of x equals. F of x equals 12. So if f of x equals 12, we're going to substitute it, f of x with 12. Now we need to solve for the input, or the x value. And so we have 8, inverse property of addition and subtraction. So we're going to subtract 8 from both sides, 0 pair. 12 minus 8 is 4. And then now we have -3x. Inverse property of multiplication, this is multiplication, is division. So we're going to divide both sides by -3. This creates a giant 1. 1 multiplied by x is x. And then 4 divided by -3 is -4/3. So x equals -4/3. Problem 8, solve for each equation. So here we need to distribute this 3 to the quantity of 2x plus 5. And when you distribute, you have to distribute to each term inside the parentheses. So we have 3 multiplied by 2x, which is 6x. 3 multiplied by a positive 5 is positive 15. Now our goal is to get x by itself, so we have positive 15 We're going to subtract 15 from both sides. What you do to one side, you do to the other. 0 pair. And now we have 3 minus 15. We have more negatives than positives, so we know it's going to be a negative. When the signs are opposite, you subtract 15 minus 3 is 12, so we get negative 12. 6x, this is multiplication. Inverse property of multiplication is division, so we're going to divide both sides by 6. We're divided by 6 because this creates the giant 1. 1 multiplied by x is x. What you do to one side, you do to the other. And we have a negative divided by a positive. Negative divided by a positive is going to be a negative. So negative 12 divided by 6 equals negative 2. So x equals negative 2. 8b, we're going to solve this equation, and first we can simplify this equation by combining like terms. We have like terms here. So we have 4a minus a gives us 3a. Then positive 1, we're going to subtract 1 from both sides. It gives us a 0 pair here. 19 minus 1 is going to give us 18. And now we have 3a. Inverse property of multiplication is division. We're going to divide by 3. That gives us the giant 1. What you do to one side, you do to the other. 18 divided by 3 is 6. A equals 6. For problem 9, we need to determine what is the domain and range for this graph. The domain are all the x values. So if we look here, I put a line where x equals 2. So our domain is going to start at x equals 2. It includes 2. So our x values are greater than or equal to 2. And as we go to the right, the x values are increasing. And since we have an arrow there, that means that it's going to go infinitely in this direction towards the positive x's. So our domain, x is greater than or equal to 2, but less than or equal to infinity. And it's going to go infinitely towards the positive x values. For our range are the y values. So now I put a line y equals 5 because this is where the y values on the y-axis stop. Since it's a closed circle, it includes the y equals 5, so it includes that. It's equal to it. So our y values are going to be less than or equal to 5 because you can see that the line, our graph stops here. It's not greater than 5, but it's less than or equal to 5. So that's why we have y is less than or equal to 5. But it's going to be greater or equal to negative infinity. And the reason why it's negative infinity is because as we go down on the y-axis, it's going down, and this arrow is telling us it's going to go infinitely, keep going in a downward direction. So y is going to be greater than or equal to negative infinity. So on the y-axis, as we go down negatively, it's going to go forever in that direction.